This is a review of a 200 amp hour lithium battery. Let's put it through a real world test and see how it performs. I don't get commissions for sales, and the battery was received from the manufacturer for testing. It is suitable for off electrical grid solar power applications, power outages, preparedness, and readiness scenarios. According to the Redodo website, this battery can be combined in series and parallel up to 4 batteries to build a bigger off-grid solar power system. The warranty period is stated to be 5 years. At 60% depth of discharge, or DOD, they suggest 15,000 cycles, which if the battery is treated properly and not abused, is an entirely reasonable expectation for the lithium iron phosphate battery chemistry. The max recommended charging current for a single 200 amp hour 12 volt battery is 40 amps or C5 or 0.2 C. Battery protection includes over and under voltage, over current, and short circuit. It does not have low temperature charge protection, but I never intend to charge frozen batteries. I will not be breaking this battery open, but based on their website photos, it appears they are using encased prismatic cells. At about 45 pounds, this 12 volt 200 amp hour battery is actually pretty big, but it weighs so much less than lead acid batteries. The 200 amp hour battery stores over 2 kilowatt hours of power while still leaving some reserve power on the table. Combining a battery of this size with a charge controller, solar panels, and an inverter could give an average family valuable backup power in an emergency or power outage. I've charged this battery up to basically 100%, and I'm ready to do the discharge test. The charging was done by 4 100-watt solar panels that are sitting outside, but just to be clear, those solar panels are not going to be charging the batteries during this test. The question is, how long can a 5000 BTU air conditioner run on a 200 amp hour battery non-stop? I will be using a 1200 watt pure sine wave inverter, LF or low frequency. I will be plugging my air conditioner into that. I will also be using this shunt, which is basically a Coulomb counting amp meter. There's the shunt right there. And that's going to tell me how many amps are leaving the battery, and it's going to keep track of all of them over time. That way I can determine whether this battery is 200 amp hours or what the actual capacity is. I've set it to 200 amp hours and 100%. I have a 150 amp A&L fuse, and this is not really a solar install, it's just a temporary setup to make sure that the voltage reporting is accurate. I have my Gochi Fix 3-in-1 digital multimeter, and that's just taking a voltage reading right at the terminals of the battery. So I'm not taking the reading over at the inverter or the load, but at the terminals of the battery themselves, which is where the most accurate voltage reading would be. I'm just going to power on the inverter, and I'm going to be using my 5000 BTU air conditioner, which probably uses around 450 watts and has quite a surge when it starts, and I'm going to use that to go ahead and stress this battery for a while and see how much capacity it actually has. Okay, the inverter is powered up. Let's go ahead and turn on the power strip. Alright, 121 volts. Now let's go ahead and turn on the air conditioner. 13.66 volts on the battery. Let's go ahead and turn on the air conditioner. (29 amps, 390 watts. And on the inverter output side, we're getting 342 watts. But the actual power coming from the battery is about 406 watts. 30 amps. Alright, a few seconds later, the voltage of the batteries dropped to 13.26 and falling. And I'm just going to let this run, and we will see how much capacity is in this battery. Alright, here's a quick update on the discharge test. We're at 96% on the battery, according to this meter anyway, according to a 200 amp hour assumed capacity. 36.2 amps, 475 watts. The voltage of the battery has dropped to 13 volts at the terminals, and there is my multimeter to verify that. 13.05 volts DC. Simply put, all batteries have what's called internal resistance, and lithium iron phosphate certainly does have some internal resistance, and it's usually measured in milliohms. And the simple fact is, the higher the internal resistance of any battery, the more it will drop under a given load. So it's just one of those things that I keep an eye on during a test. It's also important to take that voltage measurement at the terminals of the battery, not at the inverter or where the load is connected. Here's a quick update on the test. So far, it appears to be going okay. We're down to 13.04 volts at the battery terminals. Really, in the past 30 minutes, it's only dropped 0.01 of a volt, which is actually pretty good. Better than I was expecting. Pulling 37 amps from the battery, 84% based on a 200 amp hour capacity, 166 amp hours remaining. The inverter is running fine. The air conditioner is a bit noisy, but it's running. And basically, I'm just going to see how much capacity this battery actually has. Check all the cables and make sure they're not getting hot. And they do get a little warm because of the 37 amps going through, but Not too bad. Also, the amp meter estimates approximately 4 hours and 29 minutes at the current discharge rate. Of course, that's just an estimate and not 100% accurate, but you can see this test is going to be quite lengthy at the current discharge rate. Okay, we're now at 48% estimated battery capacity remaining, about 492 watts of output, 95 amp hour. The battery terminal voltage is currently at 12.9 volts. Everything seems to be running smoothly so far. The inverter's working fine. It's gotten a little bit hotter outside, so the air conditioner is using a little bit more power. And we're currently down to 38% on the battery, estimated, and pulling 499 watts. So that's definitely increased a little bit from before. 12.87 volts. Other than that, it seems to be going pretty well, and I'm just waiting to find out how much actual capacity is in this battery, and that will conclude this part of the test. 12.55 volts. And according to the amp meter, there's about 24 amp hours remaining in theory. Looks like the test is getting near to the end, 9.4 amp hours. We'll see how much farther this goes. 12.39 volts. Alright, I've decided to go ahead and end the test. I've turned the air conditioner compressor off, and we're down to 1%, so there's only a couple of amp hour left in theory. I don't really see the point in running this battery down to absolute flat dead. It's clear this battery has about 200 amp hours in it, which is what matters. It's really not a good idea to run lithium iron phosphate batteries down flat dead. I think I'm close enough. I'm satisfied that it has the capacity that it is supposed to have. It is important to test a new battery to know what it can do. Over the past few days, I have put this battery through multiple tests and cycles. It worked as advertised. Reluctantly, I also tested the overvoltage protection on the BMS, and it also worked as expected. Running an air conditioner non-stop drains this 200 amp hour battery in less than a day, but it confirmed the capacity rating on the label is accurate. I hope to use this battery in future solar-powered projects. Based on its acceptable performance, I could recommend it. There's a discount code in the description if you're interested, and remember, I don't get any commissions for sales. Thanks for watching, and thanks to Redodo for making this review possible.